Hi everybody. I'm going to do a very brief discussion about doing Flysky i6x transmitter mods, and in particular putting a module bay on the back of one. Now, when you have a cheap radio like the Flysky i6x, you're stuck with the AF-HDS2A protocol and that's it. But we do have the ability to do more if we add a module bay on the back. And for some people who already have a Flysky, they don't have a lot of money to go get an expensive $300, $400 radio. So this could be an option to add modules without going and spending $300 on a radio, then another couple hundred on a module. So let's jump in. So the first thing we need to look at is the evolution of the JR module pinout. The top always appears to be the PPM, and the third one down appears to be the VBAT, which is often a 5-volt, but depending on what your radio runs at, it can be whatever voltage your radio's at. On these, it's it's 5-6 volts, whatever you've got running out of your battery. It's fairly low. And then you've got the third one down the fourth one down is the ground. But then you go up, and you look at the second one again, and it is on some older radios. It's a 6-volt DC, which would be a regulated voltage for running a module. Some older modules or something, I don't really know. On other ones it appears to be a heartbeat. On other ones it's not used at all. On the old Turn G9X it's a second ground. And then you get into this Tyrannus here where it's not used at all again. Now the bottom one is an interesting one because this one, we see it labeled here as antenna, over here is sport, over here is RF antenna, over here is no connection, RF out, and over here as a telemetry. So those are actually all sort of related, but the antenna is the older. It's not used as an antenna anymore, it's used as a sport. But it's not actually sport, it's S-port, which is a smart audio port, which is a telemetry port, basically. So a smart audio port is an RX and a TX. So we're dealing with this radio here, the i6x, and on the back we have a training port. The training port has a PPM, a ground, and a 5-volt. And it also has a TX and an RX. Now the TX and the RX together with a certain inverter would be the same as a smart audio, but it's typically broken out for connecting to when you connect to most serial programmers and whatnot. So from work of the Drone Mesh channel, we find out that we can use the R9m module and the TBS Crossfire module and the RangeX multi-module with only the PPM, the VBAT, and the ground. So you can see there that you have to put your transmitter on the PPM output. which could be written as enabling the trainer, or depending on your software. So this is on a Untitled i6, which is the same as the Flysky i6, the Eachine i6. The one that I have is the Flysky FS-i6x. It has slightly different internals. It's a little bit different, but it's very similar to the i6s. But at any rate, we can see the back of the module here. Top's ppm, that's the positive, that's the ground. Now this is the S-port inverter. As you can see, there is such a thing as an S-port inverter that will take a S-port and a ground on one side, an RX-TX and a voltage on the other side. So that's kind of interesting. So it's theoretically possible to add a cheap S-port inverter. However, the software of the radio does not support any telemetry or other functions. So there wouldn't be no point in doing that, would there? We're stuck with the basic functions on the transmitter module. So we're stuck with it just being able to transmit the ppm we put into it. And that's it. However, when you get into some of these that have a lot of range, that's a big difference, you know. But without having that smart audio port, you cannot set any parameters in the module. So you can't change the power from your radio or whatnot. Now you may, if you've played with flight controllers, you'll say, oh, smart audio. The cameras and the VTXs can use smart audio, and then you could use your radio controller to adjust the parameters of the camera and the VTX on the fly from your OSD and your goggles sometimes. Yeah, that's all the same type of smart audio stuff that came about. So now on that port, the RX and TX here, the reason they're on there is so that when you use the cable that's supplied with your radio, you can plug it into the computer, and this end of it actually has an adapter in it, kind of like a little STM32 type of board, or that sort of a board. Usually it's a chip board, anyways, that converts USB to R32, UART, TTL, serial, or whatever that can be interpreted by the radio. Now, the more expensive radios have this right in them. You just plug it in your USB cord, but this piece is in the cord on these. You can build your own by utilizing a board and connecting it to the ground in the RX and the TX. Then it allows you to flash the radio with new firmware or those sorts of things. So that's something that's kind of interesting to know, just to understand how these things work. So this is an image of a R9m module, Flysky. The R9m module is interesting. Flysky has its own ecosystem, its own protocols, and you spend a lot of time upgrading and flashing because of compatibility changes between receivers and whatnot. And you need a more advanced radio that has the functioning within them, like that built into it with all the UART conversions and everything, so that you can just, plug them in with a cable to your radio, off it into your module bay, plug the receiver into your module bay and flash it, or plug your module into your module bay and flash it, or flash the radio itself without having to have anything more than a normal USB cord. You don't need that extra whatever. You don't need that extra UART converter in there. But this radio is simple enough that it doesn't have that inside of it. So we need PTM or PPM to go to the RX. What is the RX on here? And the VN and the ground. And we have all of those in our training port on the back of our radio. So we could take them from there if we wanted to, not modify the radio at all. So please note the R9X or R9m, whatever. R9m, sorry, that's a typo. Uses outside power. So there's a power connector here that takes it from a LiPo. So basically the 5 or 6 volts from the radio would just basically power this thing on and switch on that power. We would use that power, put that extra battery to turn it on and off. Whereas like you could TBS, the TBS Crossfire would take power directly from the radio through the VN. And interestingly, one thing I noted here is the 6 volt on second pin. If you plug this into 6 volt on second pin, when that's expecting a TX, this is RX TX. RX and TX have to cross over. So the radio is TX into the RX, to the receiver of this, right? And this is TXing into the RX of the radio. However, in our case, we have to do a PPM into here, which this can understand and won't do an RX TX exchange. It'll just use PPM instead. And same with the TBS Discovery, it'll use the PPM instead. I don't know if Express LRS has this function. I hope it would. I would expect it would, because that's kind of the standardized of it. But anyways, this would just be a not-used pin, but if it got 6 volts applied to it, I don't know how this module would handle it. Possibly not very good. 6 volt on the second pin is pretty old. So the i6x training port uses a old S-video cable. The S-video cable was used for a little bit for television, and it was better than the 3 RCA jacks, but stayed for a little bit. It was only around for 4 years or something, and they started coming with HDMI and stuff, and it just got dropped. It was in the age of VCRs and stuff. Got dropped for video. It was an old analog. It was basically the best analog you could get. It was an S-video cable. But it used an S-video cable, but an S-video cable doesn't use all the pins. So typically they won't have all the pins if you just cut the end off of it. So you basically, or if you cut it in the middle, sorry, and expose the wires, there's only like 3 wires in there, maybe 4. So basically you would have to just strip the end right out so that you get access to all the pins and start making a custom cable from there if you wanted to. Here we've got your typical one that comes for hooking up to a simulator, and this just comes out and has a PPM and ground in it, and that's actually this is your training cable. We're doing a buddy box, you're doing a simulator, whatever. Some guys just they just jump off the back of the training port here and didn't just put a 1/8 phono jack there on the back of the radio, drill it in, and then they have the more common type of a port that just uses the same cable as you'd use with most others to do a buddy box or a simulator. So here we see that there's just there and there on the back. This is the back of the training port where you would connect to. So what about using an Express LRS module? If it accepts PPM, and I don't know this, I haven't looked into it completely, then it should work. So if you can get by with PPM and a plus and a minus voltage, but we won't be able to access any telemetry information from it through our radio, and but the receiver might be able to tell that to the through smart audio to the flight controller and put that on an OSD. So that's possible. I don't know about that though. I haven't played with Express LRS. But you won't be able to change any of the powers or anything in the module. So, okay. I was thinking you can get around that probably by flashing an R9m module. And it has dip switches to change power levels on the back of it, and a bind button, which would be great with not having those menu options in your radio. Well, without a proper radio, it's harder to flash the module receiver to put Express LRS on it, or even to upgrade to R9 to stay as R9. So, however, R9m modules and receivers can be flashed without a radio through the smart audio port. And FR-Sky has the SRT toolkit that allows you to flash hooking up to a PC. And so it basically does the same type of thing as using the bottom 3 pins as hooking your receiver or your module up to the bottom 3 pins and flashing in your module bay and flashing through that would do for the radio. So basically this piece is inside of your radio already if you have more expensive radio. Receivers can be flashed by via pass-through, is what it's called, in your flight controller. So you can hook your flight controller up via USB to your computer and then use pass-through mode to flash the receivers. Now I wondered if you could do that to flash the modules too, by hooking up to the bottom 3 pins on the module. That would be interesting to find out. So the smart audio port toolkit, SRT toolkit from FR-Sky, appears to be a lightly modified generic 232 USB programmer that can switch the ground to CTC connection on and off. So on would allow flashing and off would allow configuring it. So as I was saying before, it appears that newer radios have this built into them instead of being in a cable like it used to be. So the thought becomes, instead of spending $50 on what is essentially a $2 to $5 piece of equipment, could you use an aftermarket USB to R32 adapter to go from USB to S port? And there is actually one guy who does not speak English who claims to do this and has a video, and he uses a FDTI tool adapter. Then you end up using 2 pieces of software. So once you get it hooked up, and this is actually the how you hook it up in this image, and then you have to invert the RX and TX in the software, the one piece of software. You keep running that software. Then while you're running that software, use the FR-Sky Update Sport Revision 14.zip software to flash to upgrade. Now this was not about upgrading to Express LRS. This was just about upgrading R9m software onto the R9m. But this tool here it looks like just another version of a 232 USB to UART module, and there's actually a lot of them that are just like $2 that use the same CP2102 drivers. In theory they'd work, but I don't know if the software would work like that. But the software is easy to download, so it's something to try anyway. But it'd be interesting to figure out. I need to do more research on the Express LRS modules before I'll worry about putting that on a Flysky FS-i6x. But I mean, R9m is a very good protocol, a very good range, and it's a lot cheaper than PBS Crossfire. So that could be, you might find out that you start using that and you don't care about getting Express LRS because you're just not going to go that far. Now here I was saying if I could build a LRS cheap and configure it via PC. So if you could build it and then install the software or install the firmware, I guess, to the module via PC and configure it via PC, because once you get it configured, you're going to be using the same stuff all the time. You're not going to want to change your powers once you get it configured. And if you could do that without using a radio to flash it and do your configuring and settings, then that could be the cheapest route to go, the easiest route to go to get Express LRS, which would be cat's ass to have Express LRS on one of these little radios. It would be a very, very, very cheap way. But I don't have to worry about getting there. I'm just working on doing mods and really making this radio a better radio. I've done a few mods already. So, first step is completing a GR module mod on the radio. So then I'm not really too worried about moving too quick on it. So I've already done the external antennas mod. Now the internal antennas are just plugged into the board. So all I really have to get is the new jumpers that go to they just go from that plug-in on the board to a standard screw-in antenna. Now you can get kits with 2.4 gigahertz antennas and those jumpers together on eBay or Banggood or wherever pretty darn cheap. You can do one or both aerials. I did both aerials. But I then took it a step further. The external antenna mod does give you more range, but I actually ordered two 2000 watt 2.4 gig boosters, and then I put them on top of it, and they run at 5 volts. So I put one on each antenna, and they have a little bit bigger antenna that sits on top of them. A little bit longer, a little bit bigger antenna. And so basically I've got dual 2000 watt boosters on top of my Flysky FS-i6x transmitter running the AF-HDS2A protocol, which gives really good signal. Now, that's not really something you want to do unless you're, like me out in the middle of the boonies, where you're not going to bother anybody with that extra power. And I don't know how legal it is, even technically. But I know I'm not using it near anything that can screw up anything, so like out on the freaking bald-ass prairies, it's not going to bother anybody. but it requires, really you want to use external power for it. So I've done a conversion to a USB pack on the radio, which is a lot nicer than using the batteries. I just have it kind of Velcroed to the bottom and a USB cord sticking out the back of the radio. And I'm kind of tired of that, so I've been using these Blue Hive. I got these at Canadian Tire. I've got 4 of them, and they don't go dead very often. But basically, I've got one on the boosters and one on the radio. So I power the boosters separately. And this allows me when I'm to just unplug the antennas, the antenna boosters when I'm doing a simulator or whatever. Incidentally, you can go wireless with your simulator by just using a receiver and putting the PPM out of the receiver instead of using a cord. You can just go wireless by using, you just take a receiver, you bind to the receiver, and then you just put it into your simulator cable that goes into the thing. Put a PPM output in there, and that's what it's looking for. So you just hook it up with it, and then you use a separate USB to pull a feed off the computer to power your receiver, because your receiver, choose a receiver that likes 5 volts just fine, and it works good. I did build a dongle that basically is an all-in-one. There's on this channel there's a little thing about that. But anyways, so I got these Blue Hive 5300 milliamp USB power banks, and I'm running duals. So instead of just having them Velcro to the outside, I decided I was going to build a case, and then I wanted to add a JR module bay to the back of the radio too. Now, I did hook this up so that the antenna boosters are switched on and off by a solenoid inside the radio that turns on and off with this, from the power on the motherboard when the receiver, transmitter powers up. So it just so it's not broadcasting unless the radio's on. So, I mean, the way I'm going to do this is to, I'm going to have it so that that second power bank runs either the JR module, switching on and off, with the radio, or the antenna boosters, and basically you'll either pull out the module or unplug the antenna boosters, so that you don't have both of them running at the same time competing with radio waves. And then once you disable the antenna boosters, then you basically have the radio with stubby antennas that are not very matched very well at all. And your internal broadcast power of the radio, even though it's still on, is so low it's just not that big of a deal. It's fine for playing it right next to your computer inside the house. You don't need the extra boosters on. But as far as flying anything with it, it would be pointless. But the thing is too, if you're in a place where you can't or shouldn't use the boosters, you can always unscrew them and then just screw the antennas right onto the radio and use the normal power of the radio. I don't know what the power of this radio is without the boosters, but whatever the factory power is, you can still use that. Just don't leave your boosters plugged in with no antenna. Burn them out. Anyway, so I have a 3D printer and a 3D print, so I got into designing, and I designed a new back for the case that allows for a JR module, and it allows the two modules to drop in, and you can see the power on the modules and whether they're on or off, and access the switch in the hole here. And you can see that there's a USB hole here. There's a USB. It sticks up in there, so that when you just insert it, it just plugs into the USB, and then that goes into the radio to power it. There's one in this one too. Then the solenoid's actually on the back of here on the original. When I swap backs here right away, I'll have to move it. I actually have a buck converter inside of there too that regulates at 5 volts. But I'm not sure. I may make that buck converter accessible, or put a second buck converter on. I should actually put a second buck converter on. If I install another buck converter, then I could ramp it up to 6.5 volts, which is what the minimum of the R9m likes to have for the external plug that's on the outside sticking out the back. And then I can power off the USB bank with the step-up converter. The second, instead of having a third battery. So I mean, I'll look at where I can fit that inside of there when I do this. Put this back in this case on. But it's printed. I'm just tinkering and finishing it. And that's all she wrote. So I hope this is informative for you guys. Anybody who's looking at doing mods to these things. But that's all. Have a good day. See you later.